For number 21, the easiest way we can do these, because it's hard to solve this by logs, we could probably do this one by equating the exponents. Can we think of a number that we can rewrite these using the same base? And maybe you might think base 2, but I think a better base in this case would be base 4. So if I rewrote this as base 4, this is 4 squared. And I still have raised to the 6x power. And on the other side, I can rewrite 64 as 4 to the 3rd power. Because 4 times 4 is 16 times 4 is 64. But that's also still raised to the x plus 6 power. But the reason why this works is as soon as I see that, oh, they have the same base, we can just set the exponents equal to each other. Those bases on both sides just cancel out. And I'm left with up here as 2 times 6x is equal to 3 times x plus 6. We can just distribute and solve it out. So here I get 12x is equal to 3x plus 18. If I subtract 3x on both sides, I can get 9x is equal to 18. And so we see by dividing by 9, we get x is equal to 2. For number 22, our goal is to see if there's any mistakes, and if there is one, which step did they do? So let's just start with step 1. We want to simplify log base 3 of 27, or 3 of 3 times 27. So this little multiplication here should be a little hint on what we should be doing. It looks like we might be wanting to expand, and yeah, it looks like they did. So the thing you have to remember is multiplication expands to addition. And did they use addition? Yes, they did. So step 1, that's okay. Step 2 looks like we want to probably actually evaluate these logs, so figure out what the exponents are. So what's the exponent on 3 that gives me 3? And I can see, okay, that's 1. I know 3 to the first power is 3. Now this is the one that a lot of people tend to miss, is it's not what number times 3 is 27, it's what's the exponent on 3. And they're telling us that on step 2, the answer is 9. But is really 3 to the 9th power equal to 27? No, it should be 3. 3 to the 3rd power is 27. So this 9 is wrong. So since that's the first mistake we see, it's step 2 that's incorrect. Number 23, we want to also use our properties of exponents. So we saw a couple examples of this. So if I have log of 75, I don't know what that is. But they did tell us what log of 3 is and log of 5. So if we can rewrite this in 3s and 5s, we can use our properties to try and calculate this out. So let's think. 75, well, I know that's the same thing as 3 times 25, right? It's like you have 3 quarters. But 25 is just 5 times 5. So this is the same thing as 3 times 5 times 5. And now since I have all this, I can now separate them into separate logs by expanding. And again, we saw as in the last problem that multiplication expands into addition. So let's separate each one of these into its own separate log. So this is going to be log of 3 plus another log of 5 and plus another log of 5. Or another way of writing this log of 5 twice is log of 3 plus 2 times log of 5. And then we look at these problems, oh, we need the numbers, so all we got to do is take what's given to us and actually just substitute those in. So log of 3 we see as 0.477, and then I have 2 times log of 5, which was 0.699. And do we see our answer there? It matches up with answer D. Number 24. So this is another properties of exponents. So you have to be very careful with this one. When I have log of 9 over 40, log of 9 over 40, we know that division expands into subtraction. So if I want to split that up, that's going to be equal to log of 9, the top, minus the log of the bottom, log of 40. So we're splitting up the separate ones. And I look, and log of 9 minus log of 40. Oh, that must be my answer. Right? Here is a simple log solving equation. What we want to do is get x by itself. So to get that, we have to cancel out a log base 5. Well, what's the opposite of a logarithm? Remember, is exponentiating, turning it into an exponent. So if I have a log base 5, we need to use an exponentiation with base 5. So we're going to exponentiate base 5. And that's going to cancel out. And now what you do on one side, though, we do the other. So make sure you make it 5 to the 4th power. So we turn that 4 into an exponent, base 5. And so what I have is x is equal to 5 to the 4th. Well, 5 times 5 is 25, times 5 again is 125, times 5 is 625. So we get x is equal to 625, which is answer D.